In this, we'll see the greedy algorithms. Introduction to the greedy algorithms. Suppose it is possible to build a solution through a sequence of partial solutions. At each step, we focus on one particular partial solution and we attempt to extend that solution. Ultimately, the partial solution could lead to a feasible solution, which is also optimal solution. It is just like the greedy algorithms will be solved in stages. At every stage, you will check whether you are going in the right path or not. It is just like children's playing a logics game. There will be some cubes will be there. You are going to given a task that you are supposed to build a structure like this with these cubes. Then the children will start arranging the cube or arranging the blocks in such a way that to reach the particular structure. The blocks will be arranged in a step-by-step fashion. At each step, we will focus on getting the reasonable solution, so that whenever you achieve that reasonable solution, you will try to go for adding another part of that, or you are going to provide another part of that solution, so that again you will cross check whether the recent addition is solving our purpose or not. Like that, you keep on going and finally you will build the main solution. So that is what the greedy algorithm. Please remember, greedy algorithms will work in stages, in steps. For example, so far we have seen the graph algorithms, especially like optimal spanning tree algorithms. In the optimal spanning tree algorithms, always we need to check whether adding of an edge is giving the minimum weight or not. Whenever you add any edge into the tree, minimal spanning tree, is there any cycle is there or not? So this is the every step checking. That is, at every step you need to check these two things. Once if you satisfy with that particular step, then only you will try adding the another edge into the tree. Then finally, once all the edges visiting is over, then the tree, whatever the resultant tree is there, that is the optimal spanning tree. This is a way of solving the problem in the greedy algorithms. So, a very important thing that you need to remember is greedy algorithm are solved in the stages. At every stage, you will check for whether you are moving in the right direction, and whenever you feel that okay, you are in the right direction, then we'll try solving the next step. A greedy algorithm is an algorithm which has a set of partial solutions for which a solution is built. An objective function which assigns a value to any partial solution. Then given a partial solution, we consider possible extensions of partial solution, discard any extensions which are not feasible, choose that extension which minimizes the objective function. It is just like whenever the first step has been made, consider the possible extension of the partial solution. That is, it is not complete solution. The first step is not complete solution. It's only a partial solution. Partial solution to whom? Partial towards to achieve the main solution. Okay. So whenever you consider, whenever you have done a step, then it is said to be partial solution, and you are supposed to check the feasibility or possible extension of the partial solution. With this first step, can I extend to the next step or not? Discard any extensions which are not feasible. Now consider the minimal spanning tree algorithm. Now I have placed first edge into the tree. Now I find that okay, whatever the first edge I have placed is the minimum weight edge. It is well and good. But whenever I add another edge into the tree, I need to check for whether adding of this second edge is giving the partial solution in a perfect manner or not, or adding of the next edge is forming any cycle or not. That is what the thing you are supposed to check. assume that if you might have faced that adding of the next edge is forming a cycle, then discard any extensions which are not feasible, because adding of the next edge is forming a cycle, so it is not a feasible solution. So remove that edge. Choose that extension which minimizes the objective function. That means choose any other edge which will give you the minimum distance or minimum weight to form the minimal spanning tree. So this is the way you will go for forming the complete solution. This continue until some criteria has been reached. The criteria is once all edges are visited, then the criteria was completed. So this continue until some criteria has been reached. This way of solving the problem is said to be the greedy way of solving the problems. For example, making change. Consider this commonplace example, making the exact change with the minimum number of coins. Consider the euro denominations of 1, 2, 5, 10, 20, 50 cents. Starting with an empty set of coin, add the largest coin possible into the set, which does not go over the required amount. That means I have several denomination coins. I will tell some number. I will ask you to prepare or get a number currency. Then you may go for adding of several possible denominations to reach that particular amount or the required amount. In this, you may have several options of adding, removing. But whenever you add the first one, and you will see if you satisfy with this, you will add the next denomination and you will check. Whenever you add the next denomination and check whether it is reaching the required amount or not, and is it the best way of adding. If you feel that it is good, then you will go for moving on to the next step. Otherwise, the second step will be discarded and you will choose the next coin or any other coin to add to the first step. So this is the way whenever you do it, then it's said to be a greedy algorithm. Now we'll see the greedy algorithms as according to our lecture. I have provided the lecture notes. Greedy method is a straightforward design technique that can be applied to a variety of problems. In this problem, let assume there are n inputs and require us to obtain a subset that satisfies these constraints is called a feasible solution. We need to devise a feasible solution that either maximizes or minimizes a given objective function f of n. A feasible solution that does this is called optimal solution. For example, there exists a knapsack problem is there, which is a kind of problem. A optimal spanning tree construction is a kind of problem. Shortest path algorithms, these are the kind of greedy method. In the shortest path algorithm, what we have seen, from one vertex to another vertex, we need to go in a shortest path. So first we have taken the incident vertices and we have calculated the path, and from that incident vertices to any other intermediate vertex, we have calculated the path, whichever is the minimum that we have considered. Like that, we have calculated the distance from the starting vertex to every vertex in the graph, which is called single source shortest path algorithm, in which we have seen the Dijkstra algorithm and the Flood and Warshaw's algorithm. So which are also part of this particular greedy method. So greedy algorithms are like this. Algorithm greedy of array comma n. A of 1 to n contains the inputs, that is, these are the inputs you have given. Initially the solution is empty, nothing is there, initialize the solution. For I is equal to 1 to n, do x is equal to select of a. You choose particular, you choose a solution or input a. If feasible of solution comma x, then whatever the thing you have chosen is a feasible solution, then solution is equal to union of solution comma x. Add this particular feasible solution to the solution that you have initialized. Like that, you are supposed to do for every input that you are having. It is just like I am having the edges and corresponding weights of n edges. You pick the first edge and you check whether it is a feasible solution to add or not. If the edge what you have chosen is with the minimum weight, then add it to the solution. Otherwise, you remove the particular edge or you don't consider that edge and go for the next one. Like that, you keep on doing this till the all edges are completed. This is what the greedy method of design. So the important steps for achieving greedy algorithm are, first one is feasibility. Here we check whether if satisfies all the possible problem constraints or not, so as to obtain at least one solution to our problem. So whether the function can be satisfied or not, and whether we will obtain at least one solution to our problem or not, will be checked in the feasibility of the feasibility property. Local optimal choice, as I told you, here there are local conditions and global conditions. Local conditions and global conditions must be met to achieve this particular optimization. So here local condition, local optimal choice. In this, choice should be optimum, which is selected from the current available feasible choices. Next one is unalterable. Once the choice is made and placed in the set, then any subsequent step that choice is not altered. That means if you go for the next step, after going to the next steps, the previous steps should not be altered. That means the first, whatever the step you have included into the solution set must be preserved like that. There should not be tampered or there should not be changed. These are the three properties of greedy algorithm that you are supposed to consider. For example, let us see the job scheduling algorithm. We have on a single processor computer, that means there exists only a single processor computer, means only one processor is there on a computer and there are n jobs are submitted. The jobs are submitted like this: J1, J2, J3 and so on Jn, with known running times T1, T2, T3 and so on Tn. That means first job will complete in T1 times, second job will complete in T2 time. Like that, I have done it. I have arranged it. Here the problem is to schedule these jobs in order to minimize the average waiting time. That means whenever the J1 is executing, since only one single processor is there, because here only one single processor is there, when J1 is executing, obviously the J2, J3 and so on, the remaining other jobs should wait. Once the J1 execution is over, then only the J2, J3 other executions should start. So in this process, the statement is like this, the problem is like this. We have a single processor computer and jobs are submitted like this: J1, J2, J3 and so on Jn, with known running times T1, T2, T3 and so on Tn. Here the problem is to schedule these jobs in a order to minimize the average waiting time. So in what way we can do this? To formulate a greedy algorithm to obtain an optimal solution, it is necessary to formulate an optimal measure to determine how the next job is chosen. So this is what the condition, internal condition. You have taken the first job, okay, well and good. But how can you say that, okay, this whatever the job you have selected is correct job, and how to choose the next job? Then only you can proceed further, and you can choose remaining other jobs. So it is necessary to formulate an optimization measure to determine how the next job is chosen. The objective function is like this: sigma I is equal to uh, I is equal to 1 to, or I is equal to the number of jobs. Pi is chosen as the optimization measure. So whenever you choose that, first the job should have maximum profit so as to form an optimal solution. So whatever the job you have selected must have a maximum profit to execute to reach the optimal solution. The job to be included should be completed by its deadline to form a feasible solution. These are the two conditions need to be satisfied. Second, for this, we will go for realization in terms of example. 4 jobs are submitted, J1, J2, J3, J4, and their execution times are 15, 8, 3, and 10. These are the time units respectively. If we allow these jobs based upon their arrival, then the average waiting time will be like this. As J1, J2, J3, J4, if you are allowing this J1 followed by J2 followed by J3 followed by J4, then the average waiting time will be like this. Whenever the J1 will come, J1 has come at the 0th time onto the processor. Since J1 is taking 15 time units to execute, obviously J2 has to wait till 15 time units, then J2 come into the picture. Once J2 comes into the picture, then it has to wait for 8 time units. That is, next job to need to be waited for 8 time units. That means previous 15 time units plus 8 time units, which is 23 time units. Next job has to wait for 3 time units, 23 plus 3, 26. Then J4 will be executed, and it will be executed for 10 time units, that is 36. So average waiting time of these jobs are the 0 plus 15 plus 23 plus 26 by 4, because 4 jobs are there. So 16 time units on an average, every job has to wait till for its execution. That means there is no 16 time unit execution time for even a single job also. The J1 can be computed in 15 time units. J2 can be computed in 8 time units. J3 is in 3 time units. J4 in 10 time units. But on an average, every job need to be waited for at least 16 time units. So which is not a feasible solution. So that is the reason we are going to apply a greedy method. We are going to apply, or we want to solve this problem via greedy method. In this greedy method, what will happen is arrange the execution times in the ascending order and choose the first job. Whenever you choose the first job, whenever you assign the ascending order, 3 time units execution job will come first, next 8, 10 and 15. So at the 0th time unit, J3 will come, since J3 is the corresponding 3 time units. That means J3 can be completed in the 3 time units. So first J3 will come. Next, after 3 time units, the next highest time unit, that is 8, will come. That is J2, and it will wait for 8 time units or execute for 8 time units. Then at 11, J4 will come, and by 21 it will be completed. Now the average waiting time is 0 plus 3 plus 11 plus 21 by 4, which is 35 by 4 is 8.75. Where is 16 and where is 8.75? So here 16 is not an optimal solution, but here 8.75. Now you arrange these jobs in any order, you never get the 8.75 as the time unit, or that is the execution time unit. So the optimization is achieved by executing a job in the ascending order of their required time. In this case, average waiting time is minimum. No other arrangement will give the solution less than 8.75. So that the optimal sequence is J3 followed by J2 followed by J4 followed by J1. This is the optimal sequence. So this is also called as job scheduling problem. So this job scheduling problem usually will be followed in manufacturing sector, which job to be executed first, which job to be executed next, so that the average running time of the mission must be minimum. This kind of job scheduling algorithms, not only on the production engineering or production management, but also in the CPU scheduling, also this kind of algorithms will be used. So this is also called as greedy algorithm. In the minimum optimal spanning tree, we have done the same thing. We have arranged the weights of the edges in the ascending order, and we took one edge at a time and inserted into the optimal spanning tree, and we checked whether is there any, the insertion into the tree is forming any cycle or not. If it is not forming a cycle, then we are keeping that particular edge. Otherwise, we are removing that edge till this particular process will complete, till the edges in the sorted set is completed. So this is the best example of the greedy algorithm. Now we'll see the greedy knapsack problem. See here, knapsack problem is nothing but knapsack in the sense a bag. Okay, you will be having a bag. That means it may be your college bag, or it may be your travel bag, or it may be any bag. Bag means bag only, which will hold something. So here, the every bag having a capacity. For example, if you look at laptop bag, you can place a laptop and some files in it, or maybe thin register, or some books, or some kind of things you can place. Not many things. That means every bag consisting of its capacity. If you look at a travel bag, you can place many things in that. If you take your college bag, you can place some 5 to 10 books and some one textbook or something that you can place in that. So that means it is having a bag. Every bag is having its own capacity. Here, greedy knapsack problem means here you have been given a bag and some items. Every item is having certain weight, and a bag is having the maximum capacity of weight capacity to hold the items. So whenever you place these items into the bag, each and every item is having its own weight. So whenever you place these items in the bag, you should place maximum items as possible in the bag, but it should not exceed the bag capacity. It is just like you have a travel bag with various items to place. So what you do is you will try to place as many items as possible in the travel bag, because you cannot carry separately different items. So what you do is while you are arranging the items, your clothes or maybe books or maybe any other items in the travel bag, so you will first to design a plan that okay, how we can place in the travel bag so that this bag can hold maximum number of items, and it should not disturb the, or it should not damage the travel bag, because every bag is having some weight. If you overweight it, obviously that bag may be teared or maybe damaged. So so you will make several arrangements, or you will make several permutations, combinations, you will, and finally you will fit a maximum number of items in that, so that you cannot, you should not you cannot carry separately those items. So like that, here also a knapsack is given to you, or a bag is given to you, and some objects will be given to you. So your task is you are supposed to place as many objects in the bag as many as possible, and thereby you are supposed to increase the benefit, or we can say benefit, or you are supposed to increase as many number of items as possible to place in the bag, and at the same time you should not cross the capacity of the bag. That means the holding capacity of the bag. So this is what the idea of this knapsack problem. Basically, in the knapsack problem, there are two categories. One is fractional knapsack problem, and another is the 0 by 1 knapsack problem. So there are two categories. Fractional knapsack and second one is 0 by 1 knapsack. So here fractional knapsack is nothing but, for example, uh, you have placed several items and you have some space enough, there exists some space available in the bag, but by placing the any other item or the item that will fit in that particular bag may increase the capacity of the bag. Then in such a cases, what you can do is you can fractional. That means you can put a part of that item in the bag so that it will reach the maximum size of the bag. That means in this fractional knapsack, you can place a fraction of the item. Either you may place half of the item or 1/4 of the item or 1/10 of the item in the bag, so that finally you have to fill that capacity of the bag. Where in case of 0 by 1 knapsack, you are supposed to place the item in its entirety or not at all. That means you have to place the entire item, or you should not place any other. You should not place the item. You should. That means this 0 by 1 knapsack will not allow you to put half of the or partial fraction of the item in the bag. So these are the two categories in the knapsack problem. It is just like whenever whenever you are arranging your college bag, so you may place two or three registers, okay, and one textbook and your lunch box also. But you find that after keeping lunch box, the bag is not capable of is overloaded. Then what you do is you will take out one register out and you will place the lunch box in that and you will take it. So here you are taking one register out. That means you are supposed to place the entire item in that, or you should not place the item. If this is the case, then it is 0 by 1 knapsack. That means either you have to place the item or should not place the item. That's all. This is what 0 by 1. Where in case of fractional, you can place half of that item or maybe some fraction of the item in that bag, so that it should fill the bag capacity. So this is what the fractional knapsack problem and 0 by 1 knapsack problem. Basically, the fractional knapsack problems usually will be solved using greedy algorithms. And 0 by 1 knapsack for this best way of solving is by dynamic programming. That we'll see afterwards. So in the greedy knapsack problem, we were given n objects and a knapsack or a bag. Object I has a weight Wi and knapsack has a capacity m. If a fraction, that is xi, which is between 0 to 1 of the object I is placed into the knapsack, then the profit pi and xi is earned. The object is to obtain, we can say this is the objective. Okay. Objective is to obtain a filling of a knapsack that maximizes the total profit earned. So you are supposed to place the items so that every item is having some profit. So whenever you place the items in that, then you should achieve the maximum profit. So how this maximum profit will be calculated? The fraction of the item that you place and its corresponding profit value. That is, for example, if you might have placed, if a item x1 is having the profit of 10, if you have placed half of that particular item, then you will get the half profit. So like that, how many items you place in the bag, that's related profit you will earn, and it is calculated as maximize sigma I is equal to I is lies between 1 to n profit of I xi. That means you have to maximize the profit by including the item into the bag, subject to the condition that the weight of the item I and xi is less than or equal to m, where m is the capacity of the bag, and xi is lies between 0 to 1 and I is lies between 1 to n. Okay, this is the condition, subject to the condition. Consider the following instance of the knapsack problem where n is equal to 3. That means there are n items and the maximum capacity of the bag is 20. Then P1, P2, P3, that is the profit of placing the first item is 25, profit of placing second item is 24, profit of placing third item is 15. So here corresponding weights are W1, W2, W3 are 18, 15 and 10. So there are three items. Each item weight is three items weights are 18, 15 and 10, and corresponding profits are P1, P2, P3. That means whenever you place the first item, then you will get the weight. The weight of that first item is 18, and profit you earn is 25. So like that, the three items and corresponding weights and profits. Now case 1, since this is a fractional knapsack, so you can place the fraction of the item into the bag or knapsack. So here x1, x2, x3, I want to place it as 1 by 2, 1 by 3 and 1 by 4. That means fraction of the first item, that is half of the first item, 1/3 of the second item and 1/4 of the third item. Then if it is so, then sigma wi xi is equal to 18 into 1 by 2 plus 15 into 1 by 3 plus 2.5 into 1 by 4. So whenever you do it, it is you are getting around 16.5. So our condition is Wixi should be less than or equal to m. That means whatever the value you got here, which is 16.5, is less than or equal to m, that is 20. That means we have scope to grow up to 20 because it is less than or equal to m. So let will try other fractions. So this taking of fraction is completely random in nature. You can try any possibility. There is no straightforward approach that you are supposed to use only this way of doing and all. You can apply any way of doing. You can perform any way of doing, but finally you are supposed to reach this particular thing. So now, what is this condition to be reached? That is sigma Wixi is less than or equal to m. So initially what I did is I have done half, 1/3 and 1/4. This is a random way of doing first generally. Then what I did is, and whenever we do this, along with this weights, we should also look for the profit because we are supposed to maximize the profit subject to the condition like this. So the profit what we have earned is the profit of the first item that whenever we place profit of the first item is 25. Since we have placed half of this, so half profit will be getting, that is 25 into 1 by 2 plus 24 into 1 by 3 plus 15 into 1 by 4, like that. Whenever you compute this, you will get the profit as 24. So for the weight Wixi is less than or equal to m, when you got 16.5, you got profit as 24.25. Next, what I will do is I will do another alternative. So x1, x2, x3. Previously we have taken 1 by 2, 1 by 3 and 1 by 4. Now what I did is I have taken first complete one because this is a trial and error basis. I did is this P1 is having the highest profit. So 25 is the one highest profit among all things. So what I did is I have taken full of it. And next one is 2 by 15 I made. Very small fraction. Then I didn't consider the third one. So in such cases, the weight will be is coming up to 18 plus 2 is equal to 20. That means which is Wixi is less than or equal to m, which is 20. This is satisfied. Now 25 into 1 full value I am going to take. Next 24 into 2 by 15 plus 15 into 10, 0. Here the profit what we got is 28.2. So here profit we got previously is 24 and here we got is 28.2 and weight is 20 and previously the weight value is 16.5, which is satisfying the condition. This condition is said to be local condition. As I told you previously in the last example, that you are supposed to start from a source and you have to reach a destination. You can go in any path, but subject to the condition that whenever it is 60 feet road, then you should not cross 60 kilometers per hour, and if it is a 100 feet road, you should not cross 100 kilometers per hour. These are the internal conditions. With these internal conditions, you have to reach the destination in a shortest time. So like that, here also, a condition was given here, that is sigma Wixi should be less than or equal to m, but you are supposed to maximize the profit. So in third case, what I did is I have made the first item to be 0, and next one is 2 by 3 and 1. Then you calculate the corresponding weights. So 18 into 0 is 0, 15 into 2 by 3, which is 10 here, and 10 into 1, which is 10. So which is here you are getting the weight Wixi less than or equal to m, and which is equal to 20 now here, and go for corresponding profit. So 25 into 0 plus 24 into 2 by 3 plus 10 into 1, which is coming up to 31. So previously the condition is satisfied, but we got only 28.2. But in this case, we got 31 as the profit. We always choose to maximize the profit, obviously. So this is the well and good. It is also fine. Now we tested with the full inclusion of a third item. We tested with the full inclusion of the first item. Then we'll go for another thing. Now we'll include the second item fully. Then we'll make the first item 0 and third item as half. So these are the various permutation combinations I'm trying here to go for getting the maximum profit. So Wixi is 18 into 0 plus 15 into 1 plus 10 into 1 by 2. So which is coming up to 20. So this condition is satisfied. Now check for the profit. So 25 into 0 plus 24 into 1 plus 10 into 1 by 2, which is coming up to 31.5. Okay, which is coming up to 31.5. So here we got the profit as 31.5 here. So actually here 25 into 0 is 25 plus 24 into 1 is 24. Here it is coming up to 29, not 31.5. It's coming up to 29. So among these three cases, which one is having the best one? So obviously the case 0, 2 by 3, 1 is having the best maximum profit, that is 31. So among these four cases, like that you can keep many fractions. You can have many combinations of fractions. But among these combinations, up to now, we find with this combination 0, 2 by 3, 1, so we have got the maximum profit. So this is the way of solving this particular fractional knapsack using the greedy algorithm. So the greedy knapsack problem example is like this. For algorithm will be looking like this. For I is equal to 1 to n, do xi is equal to 0.0, u is equal to m, and for I is equal to 1 to n, do. So if the weight is greater than 0, then break. Otherwise, what you do is you consider that and subtract from the already earned profit minus that weight. So whenever it reaches 0, obviously you don't need to consider the particular weight. So if I is less than or equal to n, then x of I is equal to the profit that you earn by weight of that. So the fraction of value that you consider. So this particular thing will continue till you get the maximum profit. And by taking the condition as the sigma of Wixi is less than or equal to m. So the time complexity of the greedy knapsack problem is order of n. So this is what the greedy knapsack problem. It means here you are going to take one combination at a time, and you are going to take one combination at a time and checking whether the taken combination is correct or not. Like that, you try with different fractions of the weights, of the items, and the corresponding weights and profits will be calculated. So finally, our ultimate aim is if there exist items like x1, x2, x3, and so on, xn. So you are supposed to maximize the profit, that is sigma of I lies between 1 to n. You are supposed to maximize the profit pi xi, subject to the condition that the weight should be less than or equal to the capacity of the bag. So it is just like this. So you will try all combinations and do this. Because it is a fractional knapsack problem, you can place the fraction of the item. Where in case of 0 by 1 knapsack, you can place only either complete item or you should not place that item. This is what the 0 by 1 knapsack problem. Other example of the greedy algorithm or greedy method is the construction of minimal spanning tree. Already we have seen these topics in the graph algorithms. The minimal spanning tree is nothing but the construction of a tree from a graph using the edges from the graph such that the total weight of all the edges is least. Using the vertices and edges of the given graph, we construct a tree which is connected such that the total weight of these edges is minimum. Where in the fractional knapsack problem, the problem what we have seen is the maximization problem. Maximizing the profit of including the item into the bag, okay, with subject to the local condition that Wixi is less than or equal to M, is a maximization problem. Where in case of this particular job scheduling problem, in the job scheduling problem, we have taken the minimum average time. Okay, that is the average time. We have to minimize the average time, average waiting time. So that is a minimization problem. Where in case of optimal spanning tree, this is also a minimization problem. How we can say it is a minimization? Because the total weight of the edges that we add into the tree should be minimum. So it is a minimization problem. So the newly constructed tree is called the minimal or optimal spanning tree. So for this we have seen two popular algorithms, Prim's algorithm and Kruskal algorithm. You may refer to the graph algorithms lecture video for the Prim's algorithm and Kruskal algorithms explanation. After this, we have, and see, to have an idea of that, in case of Kruskal's algorithm, what we did is, like in job scheduling algorithm, we arranged all the edges and corresponding weights in the ascending order. And we have taken one edge at a time and adding to the tree and checking the condition that whether this addition is forming a cycle or not. That is what the local condition need to be checked. Like how we have checked the Wixi is less than or equal to M in the previous case. So the local condition is whether it is forming a cycle or not. If it is not forming a cycle, then this edge will be added to the tree. Otherwise, that edge will be discarded. Like that, you are supposed to do till completion of till the last edge. And once all edges are completed, then whatever is the graph that you will get, whatever is the tree that you will get is the minimal spanning tree. So for this, we have taken the help of union and find methods to check whether the cycle exists or not. So that's what we have seen in the last videos, that is in the graph algorithms. Like that Prim's algorithm, in this also we have taken a table and we gone for arranging the or replacing the minimum weights and corresponding updating the weights of the incident edges. Like that we have filled the table. Finally, whatever the table we have got after visiting all the vertices is the final table with which we formed the edges and added to the tree. This is what the minimal spanning tree. So the minimal spanning tree that is obtained with the Kruskal algorithm and Prim's algorithm are one and the same. Then afterwards we have gone to the another method called single source shortest path algorithm. Please remember, single source shortest path algorithm means from one source you are supposed to identify shortest path to every other node in the graph. That is what is called single source shortest path algorithm. So this single source shortest path algorithm can be solved using greedy method. There is another variant of single source shortest path algorithm called all pairs shortest path algorithm. All pairs means for every vertex to every vertex. Like for example, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6. Like that 2 to 1, 2 to 4, 2 to 5, 2 to 3, 2 to 6. Like that 3 to 1, 3 to 2, 3 to 4, 3 to 5, 3 to 6. Like that every pair. This is called all pair shortest path algorithm. So this all pair shortest path algorithm can be solved using dynamic programming that we'll see afterwards. So in greedy method, we have seen greedy method means it is a way of solving the problem by taking the best optimal local solution. Then once you got the local solution, then we'll go for proceeding of the next local solution, and we combined all those local solutions then to form the global solution. And for every condition, for every local solution, we'll have some local conditions, and these local conditions has to be satisfied. And that means this greedy algorithm will be done in stages. Step by step, you will do it. In stages, you will do it. In every stage, you will check for the local optimal, that is local solution. This is the way of going for the greedy method. And under this greedy method, we have seen the examples as that is, we may use this greedy method for maximization problem or minimization problem, subject to some conditions, that is some local conditions. So in process of this, we have seen the job scheduling problem, and we have seen the knapsack problem, and we discussed that in knapsack we have two categories. One is fractional knapsack problem, another is 0 by 1 knapsack problem. Knapsack problem is dealing with the arranging of items or placing of items in a bag, that every item is having a weight and a profit. So here in the fractional knapsack problem, you are going to allow to put a fraction of the item in the bag, so that you can fit maximum number of items in the bag. At the same time, you should maximize the profit of including the items in the bag, and subject to the condition that the weight of the fraction of the weight that you include in the item should not exceed the weight bearing capacity of the bag. So that is what the sigma, that is you are supposed to maximize sigma pi xi, subject to the condition that sigma wi xi is less than or equal to m, where m is the capacity of the bag. That what we have seen previously. Then afterwards, the minimal spanning tree construction is a part of greedy method, or way of solving is also a type of greedy method. In that we have seen during the graph algorithms lectures, that is Prim's algorithm and Kruskal's algorithm, that we can solve via this method. Next one is single source shortest path algorithm, in which we are going to identify a shortest path from one single source to other vertices in the graph. During this, we have seen the Dijkstra algorithm and the Floyd and Wasser's algorithm. These two algorithms will fall under the greedy method of solving the shortest path.